at least start class. We'll try to get more at the end of class because I love hearing what you guys did. You know, it keeps me young hearing all the fun stuff you guys did. 1, 2, 4 should be in your plan book. Also, you could write down 1, 2, 5. Remember, we're on Tuesday, Wednesday, not Monday, Tuesday, right? Monday you should cross out. If you did not cross out Monday in your plan book, you should cross out Monday in your plan book. We did not have school yesterday. At least I wasn't here. 1, 2, 4 is on the back counter. If you didn't get it, get it. Our papers are in little containers now to try to keep them more separated from the other class to make it more obvious when people are grabbing the wrong paper. If you didn't turn in your homework on Friday, that would be 8 of you. 7? 8. I forget what I said. But about a third of the class, you owe me something. Right? They're not in map yet. They're just in my grade book. So if you get it turned in today, you're going to catch it before it goes in map. Right? So you're going to stop it before anything bad goes like in map. And it's like you turned it in on time. Your name tent should be out because real quick before we check homework, let's talk about your first unit or first chapter cheat sheet. Notice how cheat is in quotations. Why is that? Anyone know how like sometimes people use like those quotation type things? Sophia, thank you for raising. Sorry, Sophie. I gotta change my roster. There's still an A on this roster. Sophie, tell us why cheat is in these. Yeah, it's not like actually cheating. We're just going to call it a cheat sheet. But guys, you can, on the back of your paper, which if you want to make a new one, I love that like you guys gave me some of the things about you on this one. But if it's messy, if it bled through to the back, like you can make a new one. But what you get for clarifying purposes, what you get is half a page of printer paper. Everybody look back here. Printer paper is now stocked down here. Sometimes a binder might be slid over in front of it, but this is a whole ream. How many pages in a ream? 500. This is a whole ream of printer paper, okay? It's blank on both sides. If you need a new name tent, make it before next week, because next week is when our Chapter 1 Mastery will be. So for some chapters, I put most. I don't know why I put most, because then I give you 2 different options. Okay, so pretty much every chapter, we're going to have some kind of something to help you. Whether I give you a reference sheet of like, you need this info for the test. Or I tell you, all right, you got this much paper, put whatever you want on it. So for this chapter, you got a half sheet and put whatever you want on it. Matt? So you just want to get a new piece of paper, fold it in half, so you make sure you have half a sheet. So like a lot of your name tents got folded kind of weird. That like, yeah, Eli needs more than this because this isn't a full half sheet, right? So either he could use this or he could just get another sheet and fold it in half. You get half a piece of printer paper. Does that make sense? It doesn't have to be on your name tent. That's just me trying to get you guys to have your name tents out so I know who you are and also can see little things about you when I look at your name tent if people actually put little things about you. Questions about your cheat sheet? You get half a page. That's it, like only one side. One side, half a page. If you need front and back, you're writing down too much. Like maybe you should do more practice. Speaking of practice, let's talk about 1, 2, 3, where Tom was trying to change the probability. So when he starts out, he has 4 blue out of 12. That's really like 1/3, right? We talked about reducing fractions. However, then he goes to try to change probability. And like, take a moment to read what I did up there. I want to stop talking so you can actually look at what I did. If we want 1/10, we want 1/10. Can he take any blue away? No, he's not supposed to. So he doesn't just have 1 blue marble. How many blue marbles does he have? 4. Guys, some of us are just sitting here doing nothing. You're not even thinking. Turn your brain on. He has 4 blue marbles. He cannot get rid of any of the blue marbles. So instead, he's going to add other ones. I also have this over on my chalkboard or whiteboard. Notice how, like, I was trying to figure out what to put here. This is not equals. Like, all we need to know is what we're doing is we're messing with the situation. We are changing the probability. What I really should do is get out a game of mine, but I'll do that in a moment. So, to change a name, or what? Because you left it in my classroom. Welcome to what I do with things with Lost and Found. So, if we cannot take any glue away, let's add in some other marbles. Right? Add in 28 of whatever else, as long as it's not blue. Moving on to 81. Again, I'm recording, so this is going to end up on my YouTube, but we're not going to copy things down right now, because that's just rude. If you want to copy, you're going to go to my YouTube and copy. If I put in equal number of bears and non-bears, to bears. And then the bottom situation, if I add 2 bears, makes 6 bears, 14 total. So to get back to 1/2, we need to remove 2 bunnies, right? We can't just add 2 bears. We also need to remove bunnies. Guys, this is not the only option. There are other ways to do this. This is not the only option to make happen what he wants to happen. Sam, what's up, man?
I don't have one.
Did you miss school last week?
No.
Because you should, like, make sure you're always reading the board and doing what it says. 1, 2. Can people check their binders and make sure you don't have multiple copies of 1, 2, 3? Let me check mine. How am I going to have one more copy up here? Because this happens a lot where people take a second one or a third one thinking that you lost it, and then you realize, oh, wait, I didn't lose that. Yeah. Yeah. Sam, I'm going to print one right now. Any number over itself is 1. Guys, check 83. If you drew a picture for this, you should have definitely gotten 550 yards for 1 lap. If you only got 275 or you might have accidentally only gone half of the way around. But 1 lap should be 550 yards. So then check out my work to get to 1,000,000 yards. We're essentially doing 1,000,000 divided by 550, right? So I write that work out over here. Any questions on 83?
I got all the same things as you.
Nice. You don't always need to match me, but it's not a bad thing if you do. Sam, if you want to go to the printer in the family room, it should be coming out there. It's going to be 2 different pages, though, because mine won't print front and back. Lonnie, what's up? Yeah. I'm going to make this smaller so I have room to work. All right. So it gives it to us that Debbie is walking around a rectangular park. So let's say Debbie's on lunch break at work. Guys, you'll often see us teachers. We head over to Perry Park and we just walk. I'll put headphones on. My couple friends of mine make a podcast. I'll listen to their podcast. So 125 by 150. So if I make a picture, which guys, anytime math is difficult, making a picture tends to make it easier. So if you only add up the numbers they gave us, we get 275. But is that the whole way around the park? No. So I need to go another 150 across the bottom, and then another 125 across up here to get to 550 for each lap that we take. Does that make sense, Lonnie? Okay, what part of that doesn't make sense?
How do you know how
first things first, rectangle. Does that in your brain make a rectangle? So then they say one side is 150, the other side is 125, and I know rectangles, unless it's a square, rectangles have two different dimensions, right? Like one, and normally in my brain it's longer this way than it is this way. So I put my 150 on top and my 125s on the sides. Good there? So then, because rectangles have to be the same on top and bottom and the same on left and right, I fill in the rest of my picture like that. And if you don't have this picture drawn, you probably should. Like, go ahead and draw that.
Can I help her?
Sure,
It's
yeah.
basically finding the perimeter of the rectangle.
Yeah, so this is asking perimeter. I guess I should have said, like, it's saying what is P? Like, what is the perimeter? Because if she takes one lap, it's perimeter. Does that make sense? That what Donna said about we're really finding perimeter. So then part A just asks about 2 laps, which this might be where you're getting confused because then our answer becomes 1100 because we do this twice, right? So I go 1 lap and then another lap. How far have I actually gone? Well, 550 twice, which is 1100. That makes sense for part A. Because part B is tougher than. Part B says, if we know Debbie went a million yards, not a million laps, right? A million yards. How many laps did she walk? So unless you want to count lap after lap after lap, we have to figure out how do we split something apart. By the way, guys, those of you doing your homework right now, it's really obvious, and it shows me that you don't give a crap enough to do it on your own time. Like, it's really obvious who's doing what. I have a better vantage point. Please find a time to do homework on your own. We give you AO. We give you extensions. Sorry, Lonnie. So, I'm going to take that entire million that she walked and say, well, how did she walk it? What was everything she did? Well, everything she did was 550, right? Because every time around was 550. So I'm going to take my million, divide it by 550, and that'll tell me how many laps, because this is yards and yards, right? Because a million total yards, we know a million, and each lap was 550. So we're saying 550 times something gets a million. If we don't know the times, we do division to figure it out. Does that help? And we'll keep practicing problems like this. Again, this is another one of those, like, it doesn't have to be mastered right now. You just need to be practicing it. For what it's worth, right now, Lonnie's my favorite student. Just put it out there. Because she asks questions. Just put it out there. I don't actually have favorite students, but she's the one putting in the most, like, care. Now, if you don't have questions, great. You don't have questions to ask. But if you have questions, you better ask them, or you're essentially, like, just selling yourself short. Like, I couldn't tell if that was a hand or not. Okay, we're just dancing up here. Trapezoids are tough. Keep practicing them. They don't get easier unless you practice them. Okay, so Mr. Hall and I kind of got in a fight with each other.
Oh.
Mr. Hall's the 8th grade math teacher, and neither of us won. So, I'm debating. We'll keep figuring this out through the year, and we don't have enough time to do it today. Mr. Hall has the opposite mentality of me. He wants to say that math is easy. And by a couple months from now, we would all probably like gasp at the same time, because that's a bad word, right? So his mindset that he's trying to make kids believe is that, like, we can all do this. It's easy. Come on, we got this. We can all do this. It's easy. Come on. And I have, like, the opposite mindset of, like, this is difficult, but we can do it. We just have to put in the effort. So, I don't think I'm going to back down yet. Like, Mr. Hall and I are still kind of fighting. I don't think I'm going to back down. Like, he's older than me and a bit wiser. Yeah, he's wiser than me. But I'm going to keep saying that math is hard. Trapezoids are hard. It's hard to figure out what are the bases. If you didn't do this, grab a highlighter right now, or two. The bases have to be parallel with each other. So your bases have to be the 15 and the 11. The height has to be between the bases, and it has to be perpendicular. The height's got to be between the bases and perpendicular. So my base 1 by base 2, and my height, it doesn't matter which one's base 1 and which one's base 2. We add them up, right? It doesn't matter which one's which. But it does matter that we pay attention to which one is the height. We don't use the 9.85 in the area. We do not use this guy when we're doing area. It is unimportant. Perimeter we do. Area we don't. So there's my work. Again, this will be on my YouTube. Triangles. You guys might recognize this one from, I don't know, the Mini Mastery. Base times height. Base and height have to be perpendicular to each other. And the height is sometimes outside of the triangle, guys. The height doesn't have to be inside of the triangle. The height is just asking you how tall is it. So, if you had done this homework on Thursday, like when it was assigned, you would have done this problem before doing the quiz. It's almost like it was planned. Donna?
I have a question about like the A.
Yeah. So the trapezoid. For area or perimeter?
For like the area, for like I didn't like know how to do it, so I did like I split it where like the triangle would be like I did like the area for like the squares and triangles and added.
So you could, yeah. If you know everything you need to know, this is brilliant, guys. What Donna said she did, she split it here. Right? Am I drawing the right line? Yeah. Knew that this was 11, so this would also be 11. So this would be 4, and you could do rectangle, triangle. Essentially, you did this, but in 2 different steps, and then you put it back together. So yes, what you did is great. You just did extra work. Bethany?
I don't know if this is wrong, but for the triangle, I did 9 plus 7 on the bottom. Is that wrong?
That is not correct, because that's not part of the triangle. So this is, guys, this is tricky. I'm not going to lie to you and tell you that math is easy. Math is tricky. The height is outside of the triangle. It's literally, if you went to the highest point on the triangle, who's ever been to like Empire State Building, Sears Tower in Chicago, any other, even when you go out beyond, there's a glass room on the side of the Sears Tower. It's no longer the Sears Tower, I forget what it's called. But like you can look down and see the street. It's freaky. Like you're not above the building, you're just above nothing. So if you went out here and you dropped something, you said, oh, how far did it fall? That's the height. Triangle height is however tall it is. Sometimes it's outside the triangle. And that's why I wanted to take enough time to like review all this. Questions on that, like those, either of those? So 124 is probably going to have to go into tomorrow, but we're going to get a start on it. So 85, I think, is on your paper. So you need 124 out. You need 124 out. So, actually, let's skip right to 86 because it is on our paper. So let's look at DeMar. Anyone want to read? DeMar keeping track of coin flips? Safe. Can't let Matt always do the reading. For DeMar, 86. It's on your paper.
DeMar also kept track of the number of his flips. He wrote an experimental probability of flipping his heads as a fraction of 720. He wanted to rewrite 720 as a percent. To do so, he was and still rewrite it as a portion of 100. He started by drawing the picture at right to represent 720.
Yeah. So DeMar kept track of his coin flips. Experimental, because he did it, right? He got 7 out of 20. On your paper, you have space. I want you to quickly, with your partner or on your own, try to figure out how we could turn 7/20ths into a percent. And we had on our quiz last week a reminder, what is percent? mean? Talk with your team. You're not just talking with me.
The denominator, you like times it.
I need cards, so if you guys want to have them ready for me, that would be sweet. But they're pretty easy to grab. What'd you do with your card, Lane? Trying to stay out of the deck. Anyone want to volunteer to tell me what you think, like, visually DeMar did? Come on. Yeah, like what? So there's a visual there, or you can just tell me what math we could do. Well, how did you figure out 35? Like, I don't know that yet. Oh, we need the 20 to become 100. Why is that? What does percent mean? Yeah, percent means out of 100. Oh, so on bottom, we knew that was times 5. So on top, this will be times 5. And what's 7 times 5? Ah, 35. And then go ahead and keep going. So you said that is 35%, because if we want to take it out of the fraction, this percent symbol, guys, look up here real quick. I maybe will blow your mind. Probably not. Anyone ever notice the 1 and the 2 zeros? That the percent symbol is essentially a 1 and 2 zeros, just written differently. Guys, percent means over 100. Over 100. But when you take it and you write it with the percent sign, this means 35 out of 100. So when you go to the store and it says 20% off, that's 20 out of every 100. When I order wings almost every week. Wait, where'd it go? No, did somebody steal my Roosters thing? I had a Roosters thing up here because it expired. But all right, I'll have to show you guys tomorrow. But if I spent $100 on wings, I would save 20 because percent is out of 100. Stinks that Emery just left because we're out of time. I know I hate the math schedule, but for today we're actually out of time. So we'll pick this lesson up tomorrow. This is my homework was kind of I wasn't going to write anything else on the board than somebody asked me to. We're going to pick this up tomorrow and we'll figure out where we go from there. 125 may not officially be your homework tomorrow. Sorry, guys. I hate when we run out of time, but, you know, I can't make time.
Do we do 1, 2, 3 homework?
Yeah, you should go ahead and try, because we know what we need to.